How's it going? Hope you all are doing well today. It's still pretty cold out. Did we get snow last night? I haven't looked outside, I'm sorry. Yeah. Yeah, this is one of the earliest winter storms we've had, especially since it's still fall. All right. So, to begin with, I thought we'd go over any questions on that we had on the test two. On number two here, I know some were a little bit confused about the instructions here. But again, we just wanted to plug in each of these three things into this function. Um, that's all that we were doing there. The main issues I saw were on B and C, of course. For B, the big thing was if we plug in negative x and we square it, like we plug into this x squared right here, negative x squared is the same thing as positive x squared. Because we know squaring a negative does turn into a positive, but a number of people left off the square on the x, and that led to a little bit different answer. For f of x plus 2, when we plug that in, we do x plus 2 squared minus 4 times x plus 2 minus 1. So we actually have to go through and square the x plus 2 and then also distribute the negative 4 for the middle part. Anyway, domain problem, just set the bottom equal to 0. Most of you are okay with 3 and, well, majority of you are okay with 3 and 4. 5 on this graph. So from negative 7 to 3, that's this part of the graph right here, because it started at negative 7, x equals negative 7, to x equals negative 3. You can see this is increasing. From negative 3 to 5, we can see this is decreasing. And from 5 to 7, increasing again. And it's never constant. I think the majority of people got 8 points here, although some missed 1 or 2 parts for various reasons. On the domain here, most people got most people got the domain. It's not a number of people didn't get the range. However, when we look at domain, we look how far left and right does the graph go. And so the graph starts at negative 7 on the left, that's the leftmost point, and the rightmost point is positive 7. So the domain is negative 7 to positive 7. Okay. Now the range, we look at the lowest y value and the highest y value. The people that got this question incorrect were still looking at these same two coordinates of the endpoints. And they gave, I think it gave -4 to 3 as the answer I saw most often for the incorrect ones. And I can understand the reasoning there because you're still looking at the same coordinates. But this point on the top and this point on the bottom, these are the highest and lowest points respectively. So -7 is actually the lowest y value on this graph, and +7 is the highest y value on the graph. So we actually have the exact same range as we do domain, but again, it's for a different variable. So the first one is for the x variable here, and the second one is for the y variable here. You want to make sure we use brackets on each side. Some of you put parentheses. That's why I didn't auto-grade correctly. But I did give you most or other points back or all of the points back in some cases. If you had like a space in there or something like that. Okay. This one proved really tricky on the local extrema. Absolute maximum, absolute minimum. I think most people got that because the absolute maximum is the single highest y value on the graph, which occurs here at -3, 7. Okay, so there's our maximum, absolute maximum. And our absolute minimum, this is the lowest point on the graph, that's our 5, -7. I don't know if some of you thought this was a matching problem or something, but we don't have to use every single coordinate once here. I just did a drop-down menu just because I wanted to get 4 options, basically. So essentially, it's like 4 multiple-choice questions in one. When we look at the local maximum occurs where the graph switches from increasing to decreasing. Okay, so it cannot be an endpoint because an endpoint, we're increasing here, for instance, but it never decreases after that, just stops. So the local maximum is actually the same as the absolute maximum because here we're increasing, we hit our top point, and then we decrease after that. And for the same reasoning, 5, -7 is not only the absolute minimum, it's also the local minimum, because here it switches from decreasing to increasing. So both these points fit both maximums and both minimums. So we would actually have the same answer for both parts. -3, 7 for both maximums and 5, -7 for both minimums. Now, I know that was really confusing because a lot of people missed the local max and min on this problem. But I like this graph because it really tests our knowledge of the difference between these two things. Okay. For 8, I think most of you were okay here. Some of you just didn't answer it, which I guess you weren't feeling too confident there. Yeah. But it went pretty well overall for those of you that did answer it. 9, I think most of you got this one, that yes, it is a coordinate because if we plug in -4 for x and simplify the expression, we do get an 8 after that. 10, let me do 10. I'm going to turn on the my paper, or go back to my paper, and I'll show you this one. If f of x is x squared plus 9x plus 28. We're told f of x equals 10. Find x and the 2 points in the graph. So if f of x is 10, that means we're going to plug in 10 on the left-hand side of this equation. So 10 is equal to x squared plus 9x plus 28. Now, this is a quadratic equation, and so in order to solve it, we'll want to subtract our 10 over. And then we can factor it, so we need two numbers that multiply to 18 and add to 9, and we can see that's 6 and 3. So x plus 6 times x plus 3 equals 0. And so we get x equals negative 6, x equals negative 3 as our two solutions. Now, remember that at the beginning we plugged in f of x equals 10. F of x is basically y. So we plugged in y equals 10, and we got x equals negative 6 and x equals negative 3. So the coordinate is 6 comma 10 because we plugged in the 10, and negative 3 comma 10. I saw a couple of you that wrote 6 comma 0 and negative 3 comma 0, or you just wrote or entered the 6 and the negative 3 without the coordinate. I went back and gave you 3 of the 4 points for that problem in that case, and you noticed that on the grading, because you did have the right numbers, just not entered correctly, basically. Okay, but that is how we had to enter that, and the way I set up the grading is it would have accepted either answer in both parts, which means theoretically you could have entered 6 comma 10 for both answers, negative 6 comma 10, and it would have counted it correct. But I relied on being able to go back and look at your work to determine if you cheesed the system or not. But anyway, no one probably realized you can cheese it that way, but that's fine. If you got one, you got the other, so it wasn't a big deal, I thought. So. Alright. Let's see. This one a lot of people had trouble with. It was basically hit or miss because it is multiple choice. We have to determine which one is true for the given piecewise function. Let's see. So we have f of x is 2x plus 5 if x is less than negative 1, x squared minus 3 if x is greater than or equal to negative 1. Oh, there we go. Alright. That was 11. Alright, so our first answer, at least on how it gave it to me right now, is f of negative 1 equals 3. I'm not going to call it A, because what happens is I set it up to scramble the answers so they're not the same each time. For this one, we have to determine which part of the piecewise function do we plug in the negative 1. So this is x is greater than or equal to negative 1, so we'll plug it in here, because this is negative 1 is equal to negative 1. So we use x squared minus 3. F negative 1 is negative 1 squared minus 3, which is 1 minus 3, which is negative 2. Okay, well, we know that one's not right. So next we try f of 2 equals 9. Now f of 2 is bigger than negative 1, so we'll still use x squared minus 3. So f of 2 will be 2 squared minus 3, which is 4 minus 3, which is 1. Again, neither of those are true because it doesn't give us the number on the right at the end. So next we try f of negative 2 is equal to 1. Okay. Now, plugging in negative 2, that means negative 2 is a value that's less than negative 1. So we'll use the first part, 2x plus 5. So f of negative 2 will be 2 times negative 2 plus 5, which is negative 4 plus 5, which is 1. And so this matches finally. And so this is the correct answer, basically. And this should be the only one that works. And if we go through and do f of 3 equals negative 6, we're still using 2x plus 5. F of negative 3 is 2 times negative 3 plus 5, which is negative 6 plus 5, which is negative 1. And so that one doesn't work. So yeah, we know the only one that works is f of negative 2 equals 1 in that case. Okay. So it does require a little bit of effort to, depending on what order your answers are, if we just go through them one at a time, it may be the first one we try or maybe the later one. What makes this problematic is the way that I got the wrong answers. This function, for instance, or this value uses x squared minus 3. If you plug it into the wrong one, 2x plus 5, you actually get that 3, and that's how I got that answer as a potential solution. So we have to make sure we're plugging it into the right one, otherwise we mistakenly believe that it is true. And I think that's where I caught a lot of you on that problem. It is a little bit tricky, I admit. I need to make it challenging. Okay. And then after that, the other three problems, the graphs. Most of you were okay with the graphs. If there were any mistakes there, it was that you shifted left instead of right, or usually that was it right there. That was the only major mistakes I saw. That left instead of right, or right instead of left. So. Did y'all have other questions that you wanted me to go through on this test? Or anything else that you needed clarified? If you do have questions, or if you're not sure why something was graded a certain way, you're always welcome to message me, and I will do my best to respond to your question or your concerns or whatever, and make sure you understand why that was graded that particular way. Okay. I don't know what's going on with my webcam. Either one works, August. Because if you send me a message through Canvas, it gets sent to my email, so I'll see it in either place. Now, I would prefer Canvas actually, because on Canvas I could actually look at those on my phone. So if I'm just in the other room watching TV or whatever, I can give you all a quick response if it's something that I don't have to work too hard to respond to. If it's about a test, I'll probably need to be at my computer, but it'll work either way. But I don't have my email set up on my phone because I don't want to have to deal with that. But Canvas definitely I can read and respond to those messages as you send them. Okay. Was there anything else on the test that we needed to look at? Yeah, and honestly, it's probably easiest to go through Canvas anyway already. But yeah, that's definitely the best way to go because, like I said, it goes to my email, and if I respond to the email, it goes back to your Canvas, from what I understand. Um, and also, I can read it in Canvas on my phone, like I said. All right. Were there any questions on the homework from section 5.1? All right. So just to go over the concepts that we talked about on Monday one more time. Let me do another example. Okay, I can do that instead. 59 and 61. Yeah, either way, I need to go over something just to get us back into this thing. 59. This is page 344. We have f of x is equal to 3 times x minus 7 times x plus 3 squared. Okay. Now, the zeros in this case, we get x equals 7 and x equals negative 3. Notice the 3 on the outside. since there is not an x with it, think about it like this. If we set 3 equal to 0, does that tell us anything meaningful? And the answer is no, because 3 is not equal to 0, and there's no reason for us to say anything like that. But if they had 3x equal to 0, then x equals 0 could be a solution then. So that's what we want to make sure we're okay with there, is that if there is an x on the outside, we do get x equals 0 as one of our zeros. But if just a number by itself does not give us any additional solutions. Multiplicity, this is to the first power, and this is to the second power, so this is 1 and 2 respectively. And then the behavior based on the multiplicity, this is an odd multiplicity, so it crosses. This is an even multiplicity, and what the word that the book says is touches. That's a little bit more concise than writing intersects without crossing. So that's probably a better way of expressing that one than what I said on Monday. But. Okay, now we also need our leading term. Our leading term, if we multiply this out, we're going to get an x from the first parentheses and an x squared from the second parentheses. And if we multiply those together, that's 3x to the third. We want to make sure we include the coefficient, because if that's negative specifically, we need to know if it's negative, because that does affect the outcome here. Positive 3 doesn't make a big difference, though. So our leading term is 3x cubed, and so the far left, far right behavior now this goes back to that table I gave you, which is also in the, I believe it's in the textbook. Not in this textbook. It turned out it was in a different textbook. That's what I'm thinking of. Maybe. Yeah. It's not here. Okay. Anyway, going back to the table I gave with, hopefully you're looking at it now, with a positive coefficient and an odd exponent. It goes down left and up right. Okay. This is how I'd prefer that you work these problems. And what I'll do is I'll prompt you on the test to find each of these 5 things and sketch the graph. Although we haven't gotten to the point where we talked about sketching the graph yet. That'll come with the problems in 5.2, where we put it all together and create a graph from this information. But this is actually all the information we need to be able to create that graph. Okay. Okay. Never mind. Okay. That's fine. We'll do another one. We'll do 61 like you asked, and maybe that'll help. Let's see, 61 we have 61 is going to be a little bit different. So we look at this, and for our zeros, we just get x equals 5. Notice that this is x squared plus 4. It's not factorable, and in fact, if we solve x squared plus 4 equal to 0, that means x squared equals negative 4. We take the square root, we get imaginary answers for that part of the problem. So it's really only the single real zero that we get here. Our multiplicity is 3, and the behavior is that it crosses the x-axis at x equals 5 because of the odd multiplicity. Now our leading term, we get a 7, we get x squared that is squared, and we get an x that is cubed. So that's 7 x to the 4th times x cubed, so 7x cubed. It's actually the same as the previous one. It's down, left, and upright. Okay. Oh, yeah, because I forgot to write 7. That's the main thing. Yeah, 4 plus 3 turns out to be 7. Luckily, it still has the same outcome, but yeah, this should be 7. Yeah, and now, we didn't talk about this here, but if we have x squared squared, these are multiplied together. It's not an issue here, because even if we add them, we get the same number, but we like to get things right for the right reason. These two are multiplied, we have something raised to a power raised to another power, but then these two are added, we're multiplying two separate terms together. Okay. Yeah, those properties of exponents are important in this case. That's okay. And we'll do some more of these today where we do all these same things and then also sketch the graph of the function. So it'll be some more practice. Yeah. Alright, I'm going to look at section 5.2 now, which which is on graphing polynomial functions. Alright, let's see. Here's a good place to start. This is number 6 on page 351. We're given f of x equals x times x plus 2 squared. And again, we want to start off same steps, zeros, multiplicity, and the behavior. And then we'll get the leading term and everything else after. Now our zeros, we have 2 zeros here. What would those be? One is x equals 0. And for here, -2. Good. We just set each part equal to 0, so we get those two solutions. The multiplicity for 0, and the multiplicity for x equals -2, two. Now, what is the behavior when we have an odd multiplicity? Crosses if it's an odd multiplicity, and if it's an even multiplicity, such as we have here, what is that behavior? Touches. And again, we could say intersects without crossing, but touches is a little more, has a little more brevity, I guess. Okay. Now notice we're considering these completely separately from each other. And when we talk about the behavior, we're looking at the multiplicity, not the number itself. That's one place where I've seen students get mixed up. But we're looking at the multiplicity, and an odd multiplicity crosses, even multiplicity touches. Okay, now what is our leading term if we multiply all this together? X to the third, or x cubed. And then our far left and far right behavior. I wonder if I should get that. I wonder if I should recreate that. Yeah, down left and up right. Okay. Once again, what's happening there with down left and up right? Let me recreate that chart I gave you here. Yeah, definitely. I'm gonna see if this helps. So, it's based on our leading term, ax to the n. So a is the coefficient of the term, and n is the exponent in this case. So the two factors, or the two aspects that we use to determine the outcome here, is whether the coefficient is positive or negative, greater than 0 or less than 0, and whether the exponent is an even number or an odd number. I'm going to keep this a little more handy this time, so I don't have to do it again. Yeah, it's kind of like that, actually. We're not looking at genetics, though, but it's kind of genetics, actually. Genetics of the function. Anyway. So, in this case, we had a positive x cubed as our leading term. So, positive, that means we're on the first row. An odd exponent, so second column. So, first row, second column crosses right here. And that's why we said down left and up right. Okay. I will actually give you this as a part of your formula sheet, so you don't have to memorize it. But as we go through this, you'll probably want to keep it handy. Yes, definitely does. Well, we're not done with this problem. We still have to graph it. But I wanted to kind of pause and make sure we're okay with that far left and far right behavior. So, like I said, we still need to graph this. Now, the order in which we'll graph these is we'll do the zeros first. We'll do far left and far right second. And then we'll do the behavior in between third. Okay. So let's plot the zeros first. We have 0, we have negative 2. Okay. Now for our far left and far right behavior, we'll do that second. So we know ultimately the graph is going to continue down to the left and up to the right. So from the leftmost intercept, it continues down left, and from the rightmost intercept, it continues up right. So we actually graph what happens on the outside of these 2 points before we graph what happens on the inside. So we marked our zeros, and we know it goes down left, so from the leftmost 0 continues down. From the rightmost 0, we know it goes up right, so we draw it continuing up. Now, third, we look at the behavior based on the multiplicity. Now, at x equals 0, we know the graph crosses the axis. It crosses the axis here. And at x equals negative 2, we know it touches the axis like that. And then from there, we just kind of link up the two pieces of the graph, because they should be on the same side now. We know there aren't any other zeros, so it should not cross the axis anymore beyond intersecting here and here. So it should never intersect again between those 2 points, because we know we only have 2 zeros. Okay. The reason we do the far left and far right behavior before we do the interior behavior is we have to be able to get started, and so having these pieces of the graph here allows us to say, okay, when at x equals 0, when it crosses, we know it crosses from this side to this side and not vice versa. Okay, because this goes up, we know it's going to cross from top side to bottom side and not the other way around. Okay, so we know it goes this way. And then it comes here and it touches and then it continues down. Now, if we've done it all correctly, it should fit together perfectly. But if we've done anything incorrectly, at this point we should notice that there would be a problem with our graph, and hopefully be able to go back and correct that. Again, the way that we would notice a problem is like if we decided both of these crossed, this graph would end up on top, crossing to the top here, this one crossed to the bottom here, and to get from one part to the other, we'd have to go some other point in between to connect the two pieces. And we know that we're not supposed to cross the axis. We're not supposed to cross the axis anymore, because these are the only x-intercepts that the graph has. There shouldn't be any other point where it crosses in between. So the way that we do the graph is kind of self-checking that we haven't made any mistakes along the way. Unfortunately, if we make an even number of mistakes, it may actually still work and we create the graph. So we have to be cautious in that sense as well. So I guess it's checking if we've made an odd number of mistakes, which is not entirely reassuring, but yeah. Alright, let's do another one of these. Let's look at 12 next. Really? That's good that it's working out then. Yeah, a lot of the stuff that we cover, you've probably seen to some degree in previous classes. But yeah, usually, chapter 3, 4, or 5 is where we start to see something new. For those of you that didn't go into like pre-calculus in high school or something like that. And then definitely chapter 6. But yeah. Okay. That's correct, August. It had an x squared inside the parenthesis, so that made it not factorable. If it had been x squared minus 4, we could have factored it with the difference of squares, but the fact that it was not only x squared but plus 4 was what really made it unfactorable. So for our zeros here, we get x equals 1, negative 4, and 3. What about multiplicity for each of these? 1 on all. Yeah, all of these are raised to the first power, and we know the multiplicity comes from that exponent. And because they're all the same, they should have all the same behavior, which is crossing. Good. What about our leading term in this case? What would that be? X cubed. Yeah, these are all to the first power, so it's x to the first, x to the first, x to the first, so x cubed. I don't know why I wrote it as a subscript instead of a superscript. Okay. And again, this is just for the leading term. It's not that it's actually equal to that, but that's how we find the leading term. Okay, so we have a positive x cubed, and then what is our far left and far right behavior? Down, left, and up, right. I'm going to have to find one that's not this square, but that'll be the next problem. Okay. So we've got all that, and now we need to put it together as a graph. If x equals 1, negative 4, and positive 3. After we plot our zeros, again we do our down, left, and up, right. So here we know we'll draw it down, going down left, and from here we draw it going up right. Now another strategy we can use for graphing is after we do our down left and our up right, whatever our far left and far right behavior is, we can just pick one side to start at, and this is at negative 4. Oh yeah, most polynomials will look like some kind of wave. It's just a matter of just the actual behavior at each point. So now this is also some place where it's easy to get tripped up. Remember, this is negative 4, and now in this case it doesn't matter because it crosses at all 3 points. But if they have different behaviors and we want to look at negative 4, make sure you notice negative 4 is in the middle. It's not the first one. I see a lot of students that just go 1, 2, 3, cross, touch, cross, or whatever it happens to be, and then draw their graph, and then they're not sure why it's wrong. But notice that the zeros here are not in order from low to high. It's actually the middle number, the first number, and then the third number. And so if these had different multiplicities and different behaviors, we'd have to pay attention to that. So at negative 4, we know it crosses. And we get to 1, and at x equals 1, we know it crosses. And then at x equals 3, we know it crosses. So it crosses, crosses, and crosses. Now, because we started at the left end by the time we link up with the right end, we should have the correct behavior there. So if we had drawn this line going down instead of up, and we tried to connect this, it would actually be touching and rather than crossing, and that would tell us that something had gone wrong somewhere, either with to do with this point or with the behavior that we chose, the far left and far right. Okay. When we get to, well, not in this class, but if you get to trigonometry and you look at wave functions, specifically that'll be the sine wave and the cosine wave. Those are wave functions. So we literally call them wave functions. We don't really call polynomials wave functions, although it has similar properties in a lot of cases. No. All right. So again, let me pick one that has an even exponent, just for comparison purposes. I really like 17, but I'm going to assign that as homework. The 20 should we go? Let's do 20. Yeah, for those of you on a STEM track, after college algebra, you'll either be able to take trigonometry or pre-calculus, whichever one you would prefer, and both of those lead to calculus 1. If you feel very confident with algebra already, then you can go into trigonometry, and it's a little bit more focused on trigonometry. If you choose to go into pre-calculus next, then pre-calculus does a little bit more of a review on algebra, and then also covers a lot, but not all of the same material in trigonometry. So I think it really depends on how you feel about your algebra skills moving forward, whether you need more help, go to pre-calculus, which is a 4-hour class, and if you feel confident in your algebra skills, then you can go into trigonometry, which is a 3-hour class. And then from either one of those courses, you can then move directly into college or Calculus 1 the next semester. So we have some flexibility there. Yeah, unless you just really have a solid grasp of algebra, I would recommend pre-calculus, because the biggest thing I notice in my calculus students is a lack of algebra skills. Well, we should have an online pre-cal. Yeah, in the spring, all of our classes or most of our classes are set to be in person, at least for one section, if not more than one in some cases. That's not saying we won't start off online, but the goal is to be in the classroom eventually. It just depends on how things are in the world at that point in time, which I don't see it getting a whole lot better real quickly in 2 months, so, or 3 months, I guess. Sorry. Yeah, it's a problem, and we're all working on that now. We're all dealing with that now, I guess. You can take some summer classes if you need to catch up. Summer is actually not a bad time to take classes because you can just take one or two, and it's a little more focused. Even though the pace is faster than a normal semester, because you have less classes, it's easier to focus on them, and it doesn't feel as bad. And in fact, there are a number of students that prefer that method of delivery as far as getting through just one or two classes very quickly versus 4 or 5 classes over a longer semester. Especially math and science, I feel people would prefer to be a little bit more focused on those. Alright, for our zeros, we have x equals 2, x equals -2, and x equals -4. And we can see our multiplicity. We have an exponent of 2, an exponent of 1, and an exponent of 1. So we notice when there's no exponent listed, we just write it as a 1 in both cases. What about our behavior at these? So we do have different behaviors this time. Touch, cross, and cross. Yes, exactly. Okay, and our leading term. We have x squared, x, and x multiplied together. X to the 4. Yeah, we're just saying 2 plus 1 plus 1, so x to the 4th power. In fact, if we add together the multiplicity, that should equal our exponent. Because the number of solutions corresponds to the exponent on the polynomial. Up here, 1, 2, 3. Okay. Now, what the multiplicity doesn't tell us is if there is a coefficient. Specifically, if there's an extra number outside, we'll just include that. If that number outside is negative, that's important that we include that because it changes our answer here. So what is our behavior for x to the 4th? Far left and far right behavior. Up left and up right. We have positive coefficients, positive x to the 4th, even exponent, so first option here, up left and up right. Okay. Now to graph. Again, our zeros are 2, -2, and -4. goes up left and upright. Now, starting from the left, this is x equals -4, and at -4 we know it crosses. We get to -2 next, which crosses. And then at +2, it touches. And so it'll look something like that. Now, one thing we don't exactly know, or we can't exactly tell from what we've discovered from just the different aspects we've been looking at, we don't know exactly how far down this part of the graph goes or how far up this part of the graph goes. Now, the general rule is the further apart the points are, the further down or up the graph goes above or below the axis. But these local extrema here, that's what they actually are. We can find them using calculus, but it's not as easy with algebra. So what I would say is we not worry about this too much. If you actually put this in a graphing calculator, you might see it dip down quite a bit, but even further up here because of the greater distance between the 2 points. And we saw a similar thing on the previous graph. We had a larger distance between these 2 points than we did here, so I drew the curve a little bit further above the axis than this one was below. Okay, these are closer, so we have a smaller curve. These are farther, so we have a larger curve. We don't have to be that specific because, again, we're just trying to get a decent sketch of the graph, and the main things are knowing which direction it's going. We can certainly read whether it's increasing or decreasing, although we don't know necessarily where it switches. But yeah, so without knowing exactly how high or low the graph goes between these zeros that we found, we'll just kind of base the distance on how far apart the points are. And so this one's pretty close together, so we shouldn't go down too far, and these are further apart, so we should expect a bigger curve here. Yeah, no, that'll be calculus, because we actually have to learn how to take a derivative of a function first. And for this one, that means multiplying it out to get the full equation. So. Now, I would suspect that it's halfway between these 2 points, so I would think -3 is going to be a local minimum. We can actually plug in -3 and see what point we get. Here, I'm not as sure that it's halfway between because the behavior is a little bit different at the points. We have crossing and touching, so it's not automatically going to be halfway between, but it still might be. But yeah, there's a lot more here that we can do that we actually talk about later in Calculus 1. This is Chapter 3 of Calculus 1, where we look at how the calculus aspects affect the graph of different types of functions, such as a polynomial or a rational function or a trigonometric function. So this is something you'll see again if you do continue on to those classes. But we'll be looking at different aspects than what we're looking at here. Okay. Let's see. Well, we're kind of to the end of our time. Let me pick out some homework problems on page 351. And these are just all the same things we were doing, plus sketching the graph. Oh yeah, oscilloscopes is all about wave functions, exactly. Let's see, let's do number 5. Ooh, 9 would be good. 5 and 9. And then 11 and 17. That should be good practice. Oscilloscope shows the basically a visual representation of a sound frequency, which is generally an oscillating wave. I somehow made it more technical. Sorry about that. Oscillating means it bounces back and forth, positive, negative, positive, negative, positive, negative. Anyway, that notwithstanding, let's go ahead and end it there. So go ahead and look at these 4 problems, and the book has slightly different instructions. I just want you to do the same things we did here for section 1, and then also sketch the graph like we were doing today on these four problems. So, yeah. So have a good weekend. Stay warm. I think it'll get a little bit warmer for us today and for the rest of the week. And we'll continue on Monday with section 3. Take care all.